Hi, in this lesson we're going to look to put together all the things that we've learned in this particular theme. So we're going to look at some relative dating techniques and a little bit of absolute dating as well, which is all about trying to interpret the geology of an outcrop, where we get bedrock sticking out the ground and we can actually see the geological structure. This picture we're looking at on the screen now is an example of this. If we look carefully at this, we can start to pick out some details of the geology. But to do that, I want to show you what's in my head. Because when I look at this, I see something slightly different. What I see is this. This is the picture that's in my head when I look at that outcrop of rock. I can see I've got a distinctive bed of rock there, what we call a marker bed. That allows me to trace what's happened to that bed throughout that exposure. And I can see there that this marker bed has got broken and moved. Where you see on the diagram, point A and point B, they were once next to each other. And the beds there have been broken and one has been pushed up on top of another. It's a feature we call a thrust fault. You can see, you get an idea of how big it is from the notebook there for scale. So there's a few meters of movement here. But by looking at these geological details carefully, we can start to unpick the history. Now we're having a look at this diagram on page 24 of the Theme 9 booklet. And we've got a whole lot of information here about the different types of rock. And what I want you to do is I want you to start thinking about the relationships between them. What are the age relationships between all of these rocks? Now to do this, we need to apply the principles of relative dating, things like cross-cutting relationships, superposition, included fragments, unconformities. We also have some other data as well. We've got some graptolites that have been found in these sediments. So you need to go back into the booklet and have a look at page 12 maybe to work out what these are, what they're telling us. We also have a ratio of parent to daughter atoms of uranium to lead, and it's a 50-50 ratio in the schist there. So we've got quite a lot of information here. You can find out a little bit more about the uranium-lead dating back on page 18 of your booklet. So, what I'd like you to do is have a go at question 16 on page 24. See what you can come up with. Press pause now and have a go at that. Okay, let's see what you've found. If we look at this, let's deal with the schist first. The student who's looked at this has applied superposition and said schist must be the youngest rock. We can think that, I suppose, because it's at the top of this sequence of beds. But we've got an additional piece of information here. We've got this uranium-lead ratio of 50 to 50-50. Now, a 50-50 ratio of any radioactive element means that that's one half-life. It takes one half-life to achieve that 50-50 ratio of parent to daughter. So if we look up the half-life of of uranium-lead, we find it's 713 million years. Now, that puts us firmly back into the Precambrian period. So that schist must be Precambrian. That's quite old. But we need to think about what we know about the age of these other beds in the sequence. Now, the only information we have about the age of these other beds that we find lower down is from the graptolites. And we've got two beds here where graptolite fossils have been found. The sandstone down at the bottom, which contains Didymagraptus, the tuning fork graptolite. Now, Didymagraptus is found in the lower and middle Ordovician periods. The shale that has Monograptus in must be from the Silurian period. So we've got at the bottom of this outcrop Ordovician rocks. Higher up there we've got Silurian rocks, and right at the top we've got Precambrian rocks. That's not right. Something's happened here. We've got older rocks sitting above younger rocks. Something must have put those older rocks there. If you look carefully at the diagram, you'll see there's a fault, a thrust fault, as I was showing you earlier, that's taken older, deeper rock, the schist, and pushed it up above the younger rock, all these sediments that we can see at the bottom of this sequence. So we do need to be careful that superposition may not always very easily apply. So we now know the schist must be the oldest rock. What about the relative age of the others, though? Let me put these beds in sequence, and then I'll explain to you where I get my answers from. We know that schist must be the oldest because we've got that date telling us it must be Precambrian. The next youngest thing is the sandstone. These sedimentary rocks are in sequence. We know that because we've got Didymagraptus below Monograptus. So we've got sandstone with limestone, this Monograptus shale, and finally the other shale sitting in a sequence. Superposition tells us that that's the case. You'll then notice before conglomerate I've left a gap. That gap is boundary B. Okay. I know conglomerate must be younger than the shale because you can see it cuts across the shale. We then have our youngest rock here is the dolerite. Dolerite is cutting through these other rocks. If we put a little bit more detail in here, we've got two unconformities. The schist, remember, is regionally metamorphosed. The rest of the rocks are not, so there must be a gap in time between them. So in that unconformity, we have metamorphism, we have uplift, we've got erosion. We then have our sequence of sedimentary rocks going up to another unconformity, which is boundary B. And at that unconformity, we must have a period of folding. It's folded those sedimentary rocks. And then there's been an erosive surface. You can see boundary B is irregular. We then have deposition of the conglomerate. And then sometime after that, we must have the intrusion of that dolerite dike. We know it's a dike because it's discordant. It cuts across the beds. The actual youngest thing on this outcrop is the fault. And that's because the fault cuts everything else on this in this cross section. Okay, so we can see from this that if we think carefully and apply the logic that we use from particularly relative dating, but also with the additional information from fossils and from radiometric dating, we can actually establish the full history of an area by looking at the relationship between these rocks. This will come up in your exam in some form you will be asked to use these skills. So it's really important that we get to grips with how this works. We'll have another practice using some similar data in the next lesson. I'll see you then.